Hi, welcome to Raw Math. Today I'm doing a series of videos on functions and function notation. In this video, I want to start off with talking about the idea of what function notation is. So traditionally we would write an equation like y equals x squared minus 7x minus 8. The thing is, function notation, and I'm going to use g of x in this case, so g of x equals x squared minus 7x minus 8 takes the y and replaces it with g of x. Y and g of x are two ways of writing the exact same thing. It is two names for the same thing. It's like if you call someone by their first name or their last name. You're calling the same person, you're using the same name. It's like if you have a cat and you named your cat Kitty, and then you start calling them, murder muffins or murder mittens or whatever you want to call your kitty cat. Sometimes you give nicknames to things. Two names, same item. This isn't multiplication, g times x, it's g of x. It's telling you the input value that's going into the function. One of the reasons we do this is because I can then say g of negative 10. Basically, I'm saying, tell me the value of y when x is negative 10. I don't need to write a full sentence. I can just say g of negative 10, and it is clear what I'm asking for. So what I'm going to do is I'm going to write negative 10 squared minus 7 times negative 10 minus 8. I use those parentheses because when I multiply that negative 10, I take that negative 10 and square it, I want to make sure I get a positive 100, not a negative 100. And if I don't write the parentheses, that negative is technically not being squared. So to be technically correct, I need the parentheses. So yes, you do need the parentheses. This becomes 100, negative times a negative is a positive, plus 70, minus 8. So 170 minus 8, g of negative 10 is 162. This answer is perfectly acceptable. It is a lovely answer. Another reason besides the simplicity of g of negative 10 that mathematicians really like function notation is we often graph. Graphs are the visual representation of the math we're utilizing, and you see graphs all the time. If I wanted to graph this, I would use an ordered pair, and in this case, the ordered pair would be negative 10, 162. The negative 10 and the 162 are in the exact order that I graph it, the same order as the function notation. I don't have to switch anything. I don't have to make it at all complicated. Function notation and the ordered pair are in the same order, which is nice. So for the second one, I have 6 squared minus 7 times 6 minus 8. Again, I didn't need a full sentence. Find y when x equals 6. Nope. G of 6 gave me the whole question without any extra words. 36 minus 42 minus 8. Now, if you're flexible in your math, you might notice that negative 42 minus 8 is negative 50 and 36 minus 50 is negative 14. Amazing. But that's not how I'm going to solve this. I'm going to use the traditional order of operation and solve from left to right. I'm going to take negative 36 minus 42 and get a negative 6 minus 8. I'm going to get that g of 6 equals negative 14. I can, of course, once again, write this as an ordered pair. 6, negative 14. I don't have to. This is not in the orders, in the directions of the problem. There's nothing that says write this as an ordered pair. I'm just doing this for a little bit of extra credit because it is sometimes written in the rules. I often will write it. Teachers will often write, leave your answer as an ordered pair. So I'm adding this in case this is part of what you are told to do. Okay. Next problem, g of 0. 0 is my favorite. My suggestion to you is do not start like this with your 0 term. For some reason, when students substitute a 0 into an x term, It sometimes gets translated as a 1. I've never really understood why. Just don't write those terms. We just get a -8. G of 0, -8, 0, -8. This is our vertical intercept where we cross that vertical axis. Boom, done, yay. As simple as that was, our next one is a little bit more challenging, more interesting. Never trust a teacher that says something is interesting. We're going to put x minus 8 into each of our x's. X minus 8 squared minus 7 times x minus 8 minus 8. All right, so this is not x minus 64 or x plus 64. We are going to have to do a little bit of work. I'm going to expand it out. X minus 8 times x minus 8. Now I'm going to use the distributive property with stacking. If this is something that challenges you, I do have a bunch of videos on this. So I'm going to distribute the x to get x squared minus 8x. I'm going to distribute the -8 through to get -8x plus 64. Before I add down, I am going to finish all of the rest of it. I'm going to take this -7 and distribute, and I'm going to continue stacking my like terms. -7 times x is a -7x. -7 times 8 is a positive 56. And then I'm going to bring this -8 down so I have everything stacked up. Now I'm going to add down x squared. All three of these terms are negative, so I just have to add them. 8 plus 8 is 16. 16 plus 7 is a 23. All right. 64 plus 56, let's see, 60 plus 50 is 110, and another 10 is 120. 120 minus 8 is 112. So g of x minus 8 is that. Perfect, done. Now I do, as always, have the option of writing this as an ordered pair if I want to. That is always the option. I can write x minus 8 as my input, and then x squared minus 23x plus 112 as my output. That is an option if you are asked to translate this into an ordered pair. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video.